All right, here's our first video in Unit 2A, the second unit of our 8th grade math year. And this second unit is going to talk about proportional and linear relationships. That's right, relationships, relationships, relationships. Yep, did you know that numbers can have relationships? Yeah, numbers can have relationships. Like, for instance, there's a relationship between the number of quarters you have and the number of dollars you have. Because if you have 4 quarters, you basically have $1, right? And if you have 8 quarters, you basically have $2, don't you? Yeah. These are what we call proportions, when numbers have relationships. Okay, so let me see if I can explain proportions to you this way. I've got a couple of families that I know. This family right here is the Johnson family, and there are 4 people in the Johnson family. And of the 4 people in the Johnson family, 2 of them are male. Okay, I also know another family. This is the Weisenheimer family, and the Weisenheimer family has 2 people. And in the Weisenheimer family, of those 2 people, 1 is male. So, 2 out of 4 and 1 out of 2. Oh, those are the same number. These numbers form a proportion. A proportion is a pair of equal ratios because 2 out of 4 is equal to 1 out of 2. And what we're basically saying here is that proportions are proportional. So what does proportion and proportional mean? Proportional relationships are relationships where there's an equal relationship there, or there's a constant relationship that doesn't change. So a ratio is when you compare 2 different numbers. Like you might say at a party, there's 20 girls and 10 guys. That's a comparison of the number of girls and the number of guys. A proportion is a set of 2 equal ratios. So a proportion is when one ratio is equal to another ratio, and a proportional relationship is when numbers have a relationship with each other where there's a constant relationship between the pairs of numbers. So, how can you tell if 2 ratios are proportional? Well, if you take the first ratio and simplify it, and then take the second ratio and simplify that, you can tell that these 2 ratios form a proportion because they both reduce and simplify to the same ratio. So if they make a match, then they are proportional. And if they don't match, they're not proportional. Okay, I think you probably already knew that, but let's test you. Practice problem number 1. Do these 2 ratios form a proportion? Is there a proportional relationship between these numbers? All right. We know that there's a proportional relationship between dollars and quarters because we already said so. But let's just take a look at if you had $1, you would have 4 quarters. And if you had $2, you would have 8 quarters. And if you had $3, how many quarters is that? That's 12 quarters. And if you had $4 in quarters, that would be 16 quarters, and so on and so forth. Is this a proportional relationship? Yeah, because the relationship stays the same no matter how many dollars you have. There's always going to be a proportional number of quarters. Basically what we're doing here is you take the number of dollars and you multiply it by 4 to figure out the number of quarters. And it works if you have $2, you multiply that by 4 to get 8 quarters. And if you have $3, you multiply that number by 4 to get 12 quarters. And it works every single time. We're just taking the number of dollars and multiplying it by 4 to get the number of quarters. Now, if you're noticing that we're multiplying by 4 constantly, we're going to call that 4 a constant of proportionality. The constant of proportionality is the number that rules the proportion, okay? Because you're quadrupling the number of dollars every time. You're timesing it by 4. We would say that that 4 is a constant in this relationship. Now, When we talk about a constant of proportionality, I'm going to spell it this way because in math, we use the letter K to represent the constant of proportionality in any proportional relationship. So, in this proportional relationship, K equals 4. The constant of proportionality equals 4. So a constant of proportionality is the number that rules the proportional relationship. Okay, and in this case, it's the number that you multiply dollars by to get quarters. Now, you might have a different proportional relationship, like let's say for every 1 foot you have 12 inches, and for 2 feet you have 24 inches, and 3 feet make 36 inches, and so on and so forth. This does have a constant of proportionality because there is a proportional relationship between feet and inches. But in this case, K is going to equal 12 because that's what you multiply x by to get y. And we could even make an equation out of this proportional relationship because we could say to figure out what y equals, you're always going to take x and multiply it by 12. Okay, so that's what we do with proportional relationships. They always have a y equals k times x formula. In other words, one variable equals the constant of proportionality times the other variable. Remember, k is the constant of proportionality, and to find that number, you just have to figure out what are you multiplying one number by to get the other number. In this case, it's 12. Now, you can figure it out also by just taking the y and dividing it by the x, and that should give you the constant of proportionality. So, for this practice problem, I want you to look at the proportional relationship in the table, and I want you to figure out what is the constant of proportionality for this proportional relationship. And then, could you write an equation for this proportional relationship? And bonus points if you can think of a real-life situation that has this particular kind of proportional relationship. Okay, now, we're talking about proportions and proportional relationships. What you might not know is that they're kind of magical. What if we did something kind of weird? What if we went all crisscrossy and zigzaggy, and what if we multiplied the numbers that are diagonal from each other and did 20 times 17 and 10 times 34? This would be what are called cross products because you're multiplying diagonally. The magic of proportions is that they should come out the same. 20 times 17 is 340, and 10 times 34 is also 340, because when two ratios are proportional, when there is a proportional relationship between the numbers, the cross products will always be equal. So, is 3/4 equal to 75/100ths? Is that a proportional relationship? Well, is 3 times 100 equal to 4 times 75? Actually, 3 times 100 is 300, and 4 times 75 is 300. So yes, that is a proportional relationship. All right, practice problem 3. Are these two ratios proportional? Yes or no? Now, you can use the magical quality of cross products to help you solve proportions. If x is 2 and y is 5, then what would x be when y is 10? Well, we know that 2 times 10 has to be equal to 5 times x. So, we can just solve this relationship by figuring out 5 times what makes 20? Well, 5 times 4 makes 20, so x must be 4. And you can use cross products to help you solve for missing pieces in proportional relationships. So, let's try this one. 2 and v equals 1 and 8. Okay, well v would have to be 16 because 2 times 8 would have to equal v times 1. Alright, now you try this. Solve this proportion. What would z have to be in order to make this a proportional relationship. And if you can handle this problem, then you're pretty much all set on proportional relationships. So, thanks for watching. I hope you took some good notes, and I will see you tomorrow.